Hi, in the previous video we have completed a web scraping project on an e-commerce page, this Capelli Sport, where we obtained the names of the products along with their prices. In that video we already talked about this powerful tool, but in this video what we are going to do is take this scraping code, this Python code we developed here using Conda and Jupyter Notebook, and turn it into a web application. So the goal is to take the process we have already automated here for scraping product names and prices and make it accessible in a simple and user-friendly way. Alright, now as you can see, this is the application up and running. And when you go to the product scraping section in the navigation bar, it triggers the scraping process to fetch the latest product prices as we program it in Jupyter Notebook. So let's press here, product scraping, and it will take a little bit because the process of retrieving the data takes a little time, but it's already there. And here's a list of products that we scraped from the e-commerce website along with their prices. And as you can see, the application displays all the product names and their corresponding prices in a clear and organized manner. So each time you visit this section, the web scraping script is automatically triggered in the background, fetching the latest data and ensuring everything is up to date. And this eliminates the need for any manual intervention as the application handles the entire process. The products are shown in a table format, making it easy for users to browse through the list. And there is even an option always to refresh the data if needed. And at the bottom of the product list, you will notice there is a button that allows you to export the data to an Excel file. So just with one click, the entire list is saved as an Excel file, ready for use. Alright, so, and one important thing to keep in mind is that since the scraping code was written in Python, in order to develop this application we need to use a technology that works well with Python. And for this we will use Flask, which is a web framework that allows us to create an efficient backend for displaying the products without any problem. So if you're someone who usually works with other technologies like Node.js or Java to develop applications, it's important to note that for this project you need to use a technology that is compatible with Python, since our web scraping or any code related to machine learning or data science that you want to incorporate into a web application could be written in Python, and for that you need a framework that is compatible with Python. So for this reason, before diving into the code of our web scraping application, we are first going to learn how to set up a Flask project from scratch. Understanding how to get Flask up and running is essential, especially if you're coming from a background where you typically work with other kind of technologies. So first we will cover how to install Flask, create a virtual environment, and set up the basic folder structure for your project. This will include creating the necessary files like app.py instead of app.js, where the main logic of the web application will reside, and how to configure Flask to run your application locally. And once we have the Flask project fully set up, I will walk you through how to integrate this scrapping code we have already developed. So to start working on this project, we will drop this empty folder into Visual Studio Code. Remember, this empty folder has the name of your project, which you can choose yourself. And now you need to have a terminal located inside the project directory, and for that you can run the command Ctrl+Shift+P. And among the packages we need to install for this project, first of all we have Flask, which is a framework for Python that help us build applications and APIs by managing routes, handling requests, and all the things we do with backend servers. And then we need to include all the packages we use in the web scraping project we did in the previous video. And now we press enter, and the packages will be installed, allowing us to implement our project. Originally developed in Jupyter Notebook with Conda, now into this Flask web application. And now we are going to create the main file app.py, which will start the server and serve as the primary file of the project. And now we're going to write the basic setup code for start this Flask development server. So just by importing Flask and setting up this basic configuration, we are able to start the Flask development server on port 3000. This debug through flag allows us to see detailed errors message and how to reload the server when changes are made to the code. So let's try running this command, Python app.py, and this will start the server. And in localhost 3000 we get this message, which indicates that the Flask application is running correctly, but there are no routes defined yet. In simple terms, the server doesn't know what to show, which is why you see this error, but that's part of the task we are going to do right now. Now to continue with our project, we will create the first route that renders something. And first we will create a folder called templates. And inside this folder we will create a new file called index.html. And here you can add some basic HTML content just to display on localhost when we create our first route. And now we'll create a route that will display the content that we create here. So this is the way we declare a route in Flask. This is called a Flask decorator, which tells Flask to execute this index function when a user accesses to the root URL. So this is basically how Flask defines routes. First, Flask decorator, then the function that is executed within this decorator, and then the URL that we specify to be triggered. Naturally, the function that we define within the route is responsible for handling the logic for the route and return the response. In this case, we are simply using this function to render an HTML template. Notice that in order to render this HTML template, we added here a function provided by Flask, which helps to separate your Python code from the HTML content. And as it is a function provided by Flask, we have to import it here. And now we are able to combine the Python logic with HTML to generate dynamic web pages. Let's see now what we get in localhost. And that's the message we added in our HTML, right? Alright, so now that we have covered the basics of setting up a Flask project, I'm going to walk you through how we take the web scraping process that we have done previously in a Conda environment to turn it into a full web Flask application. It's like we transform that web scraping from Conda into a dynamic web application that can be accessed by anyone through their browser. It's not so complicated. The code remains quite the same in terms of logic. We are not introducing anything new in that aspect. All we are doing here is transferring the web scraping logic we previously developed in Conda into the different routes of this Flask backend. This will allow us to make the scraping functionality accessible through a web interface. You will see the main change here is the structure. Instead of running the script as a standalone program, we will integrate it into a web application where users can trigger the scraping process by just visiting certain routes. So, in addition to the Flask module we imported at the beginning, along with this render template, we add the request beautiful soup, pandas, and bytes.io for exporting for Excel export, same as Conda in Jupyter Notebook in that aspect. And then outside the whole logic, we define the base URL of the website we are scraping. In this way, it can be reused in multiple parts of the code without needing to hard code it again. This makes the code cleaner and easier to maintain. And then we continue with our application, and we encounter the most important function of the application, which performs the core task that the entire application is built around, scraping data from the website. And if you remember the previous video, it's quite the same as the function we wrote at the end of our project. So it was all about copy this code and paste it in this scrape paradox function. So if you want to understand in detail how this function collects information from the web page, I recommend watching the previous video where everything is explained. Alright, so and something else to take into account is that this function is also defined separately from the routes that are part of the application. This function focuses only on scraping and collecting data, while the route handlers manage HTTP interaction and rendering templates. Alright, so now let's move on examining the routes in our Flask application. First, let's start with the route we reviewed earlier. This route basically represents the root URL of the application. So when a user navigates to the home page, this route will be triggered, and it renders the index.html, which is the home page of the application. In the templates folder, there are three files: base HTML, index HTML, and scrape HTML. The base HTML serves as the base layout for the application. It contains the overall structure of the HTML pages, including the headers and any other common elements that should be present across multiple pages. And the index.html extends the base HTML templates. In Flask templating, extending a base template means that one template file inherits the layout and structure defined in another template file. The base template contains the common structure and layout that should be present on all or most pages of the application. This typically includes elements such as header, navigation. In this case, it's this navigation is present all the time. And index and scrape are like child template that extends the base template by inheriting its structure and layout. And it fills in the content for the blocks defined in the base HTML file. Specifically, it sets the page title to home and provides content for the block content section. Here, this section. And then we have scrape HTML. This file also extends the base HTML template and is used to display the result of the product scraping. It sets a different title and provides a table listing the scraped products. And then we define another route that specifies that the scrape function should be executed when the URL path scrape is accessed. So when we press here, product scraping, this route handler will be triggered. So after accessing this URL, this line then calls the function scrape products, which performs the web scraping and returns a list of products. Each product is represented as a dictionary with title and price keys. So far is the flow is when a user visits scrape, the function scrape products is called to retrieve the data, and this data is then processed and passed to the scrape HTML. This template, scrape HTML template, which then displays the product information. Alright? This products variable is the one where we store the whole list. And what this template does is iterating over this list and displaying all the products name and with its prices, with their prices. Then in the following line we process the list of products by enumerating them, giving each product an index starting from 1, and then it sends that modified list, enumerated products, to be rendered in the HTML template. And how we do that? The function enumerate takes an iterable, in this case products, and returns an iterator that produces tuples, where the first element is the index starting from 0 by default, and the second element is a product. And the result by doing this will be a list of dictionaries where each product is assigned an index and it includes its title and price.